Let's look at writing a polynomial as a product of linear factors. What do we mean by linear factors? Things like this. X minus 2. That's a factor. And if you graph that function, it's going to be a straight line function. That's a linear factor. Oopsies. Linear factor. But if you have something like this, x squared plus 5, this is a quadratic factor. So what they want us to do is break down a polynomial so that all the pieces that multiplies to give us the big polynomial is linear. So we're breaking down a big polynomial into smaller linear pieces. So for example, if I give you something like, here is 105, and I ask you to break it down into prime numbers, you can do something like, I'm not sure, can I do 5 times 21 first, right? 5 times 21 is 105, and I can keep the 5 the same, but 21 can be broken down into 3 times 7. So I get to say 105 is same as 5 times 3 times 7. So we're doing something very similar using polynomial functions. We're going to go ahead and break down a big polynomial into smaller pieces, and we are doing that so that we can actually solve for 0. And when things are small, linear factors, it's very easy to tell the zeros. Like for example, if I give you that x minus 2, if a factor is x minus 2, you know obviously, x equals positive 2 is a 0 or an x-intercept. So the goal later, we're trying to graph these functions without a graphing calculator. But let's go ahead and use our division skills that we learned in this section to break down this polynomial g of x. For the polynomial below, 1 is a 0. What a useful information they're just giving us. Go ahead and highlight that. When they say 1 is a 0, what I know is that because 1 is a 0, x minus 1 is a factor. Yay, we already got one factor because they told us 1 is a 0. All right, they said express g of x as a product of linear factors. I want you to look at the degree of this polynomial. Degree is 3. That means we're going to need to find 3 zeros, leading us with 3 factors. We know one already. So let's go ahead and use that clue to find the rest of them. Listen guys, we need 3 factors. We already know one of them, so we need to find 2 more. Let's find 2 more. And I'll do it by division. I'll go ahead and divide g of x by x minus 1. It's your choice. You choose either long division or synthetic division. I'm going to do synthetic division. I'll put the 1 in the little box, okay, because they said 1 is a 0. And I'll put the coefficients outside. 1 for the leading coefficient. Next coefficient is negative 5. Next is positive 7. And the constant is negative 3. If you're wondering where is she getting those numbers from, make sure you come back after watching synthetic division video. I'm getting these numbers from the coefficients. Now, I am going to start the synthetic division. Bring down the 1 and multiply. 1 times 1 is 1. Add vertically to get negative 4. Multiply again to get negative 4. Add to get 0. Guys, if x minus 1 is a factor and if 1 is a 0, what should we get as a remainder if they gave us the right information? If they're not lying, the remainder better come out to be 0. Let's see. 1 times 3 is 3. And look at that. Remainder is 0. This just proves that x minus 1 is a factor. Yay! And every semester, students would ask, so what was the purpose of this division? Were we just trying to see if they were giving us the right information? That's not just it. Because now what we are going to do is we're going to use the quotient. We're going to go ahead and use the quotient to break this g of x down even more. All right, let me sit down. Okay, so what we got is we were able to break down this g of x into two pieces. Let me go ahead and write the quotient, okay? The quotient is, notice we divided x to the third power by x to the first power. So the degree is going to be x squared. So 1x squared minus 4x plus 3. Guys, that's the quotient. So what we got is this is a quadratic factor. Got a quadratic factor. So far, we broke down g of x as this quadratic factor times the linear factor of x minus 1. Right? Because x minus 1 is a factor, and we got that from the given information. We also have a quadratic factor. Just like how I was breaking down my special number 105 into 5 times 21, we got a prime factor and a little bigger one that can be broken down one more step. That's what's going on right now. So let's break down the quadratic factor. And for this example, I believe I gave you one that is factorable. Okay, focusing on this quadratic factor, do you see we can factor this into x minus 3 and x minus 1? Yep. And we can bring down that x minus 1. Because this is factorable, we are done. Okay, we are done because we got it down into 3 linear factors. But hey, I noticed something. Don't we have x minus 1 listed twice? Maybe we can go ahead and write this answer in this way. We can do x minus 1 squared. So what we can do is we can connect it to the multiplicity idea that we are going to be looking at, or we already looked at in section 2.2, that if we graph this function, the graph will cross the x-axis at 3, but it will bounce the x-axis at positive 1. Let's see if that is true, okay? So I hope you guys are making these connections, the topics that we already talked about. So I'm going to go to Desmos graphing calculator, and I will graph this. To know if you did this right, I guess one way of checking your answer is graphing the original function and graphing the one that we wrote after breaking it down. And if they are truly the same thing, we should only see one graph. You see how it used to be, hold on, if I just graph the red one, but if I graph our answer, they're the same exact thing, so I only see one graph. So we did something right. Let's talk about that multiplicity real quick though. So review, if you have x minus 3, the 0 is positive 3. You notice how the power or the exponent of x minus 3 is just 1. They didn't write it down, but that factor happened once. Because that's an odd multiplicity, the graph will cross at 3. It crossed at 3. Ooh, to the other side. But at positive 1, the 0 of positive 1 has an even multiplicity, so the graph will bounce. You see, when it gets to 1, it bounces right down to the bottom. So I hope you are making this connection, looking at these multiplicity and the zeros. But this section, we use division to break down a polynomial to write a long polynomial function in a factored form. Okay, I will go ahead and now go over the second problem. On the second one, we're still writing a polynomial as a product of linear factors. And this section and the next, we will be given a starting point. They said for a polynomial below, they're giving us that -2 is a 0. So what does that mean? If -2 is a 0, then x plus 2 is a factor. Okay, so we have one factor already, and looking at the degree of this polynomial, which is 3, we just need to find 2 more, because we need 3 in total. So let's go ahead and start by dividing. Step 1, divide f of x by x plus 2. Like I said, you have a choice. You can do long division. I tend to stick with just synthetic division when I am dividing by a linear factor. Okay, coefficients are 1, -6, -2, and 28. When I am done with this, the quotient will be a quadratic, because if you divide a cubic by a linear, 3 minus 1 will give us the degree of 2. So we're going to get a quadratic after this. So 1 comes down, multiply and add. Multiply and add. And look at this. -2 times 14 is -28, and we get the remainder of 0. And that is exactly what we expected. Because if x plus 2 is a factor, remainder has to be 0. So let's go ahead and write the quotient, which is 1x squared minus 8x plus 14. And this is a quadratic factor. This is a quadratic factor. So what we got so far is we were able to break down f of x as x squared minus 8x plus 14 and x plus 2. So it depends. From this point on, we need to see if this x squared minus 8x plus 14 is factorable. If it is factorable, it's going to be super easy. So is x squared minus 8x plus 14 factorable? Let's try. What times what gives me 14? The only thing that comes to my mind is 7 times 2. But they're not going to add up to -8. So, and 1 and 14 too, right? 1 and 14. But they're not going to add up to -8. So this is not factorable. Not factorable. So this is where we have to use either the quadratic formula or completing the square method. Okay, this is where we have to use either of those methods, and I like to use completing the square. So let me go ahead and complete the square. Solve this. I will set it equal to 0, and I will go ahead and temporarily move that 14 to the other side. Notice how it was a positive 14, but I move it to the right side, so it became a -14. I did that because now I want to complete a square. I'm going to add a number to both sides. And that number is special number because it's going to complete the square for me. And how do we figure out that number? It's always going to be half of the middle number squared. So half of -8 squared is -4 squared, 16. So I'm going to add 16 to both sides. If I do that, the left side is factorable. The left side of the equal sign is now x minus 4 times x minus 4, right? And the right side of the equal sign is simply 2. I can write x minus 4 times x minus 4 as x minus 4 squared. And this is a good starting point for me to now solve for x. I'll take square root of both sides. I will get x minus 4 equals plus or minus square root of 2, which cannot be simplified. But I'm just one step away. Let me move this -4 to the other side. We get x equals positive 4 plus or minus square root of 2. So we got 2 more zeros. We found 2 more zeros. Okay? The zeros are positive 4 plus square root of 2 and 4 minus square root of 2. So using those zeros, I'll go ahead and list the zeros. Zeros are 4 plus square root of 2 and 4 minus square root of 2. And the last zero they gave us was negative 2. So if I have 3 zeros, guys, take a look. I have 1, 2, 3 zeros. I should be able to write 3 linear factors. So here I go. Using these zeros, I'm going to go ahead and write f of x. Remember, factor form is always x minus whatever that 0 is, right? So what I will do is I will put parentheses around my special looking zeros. And then I will go ahead and get started. So first zero is like this. X minus 4 plus square root of 2. It's always x minus, you guys. Next factor. Next factor is x minus, and I'm looking at the second one, parenthesis 4 minus square root of 2. I close parenthesis. And the very last zero, the one that they gave us, is x minus negative 2, which will give us x plus 2. And we don't have to simplify any further. In fact, if you multiply this out, we will go right back to where we started. So this last one was much more challenging. Why? Because when we got to, because I know you can do the division. I mean, this part is okay. You guys can figure out the remainder is 0 and figure out the quadratic factor from the quotient. But this problem was much more challenging compared to the previous one because the quadratic factor was not factorable. That's why I had to use a method here called completing the square method to solve for the zeros. Now, this is completing the square method is something that you probably learned in Algebra 2 or Algebra 1. Another method that you can use is or use quadratic formula. Maybe on my next example, I will use a quadratic formula. It's completely up to you, but I need you to remember these quadratic solving method. There are a couple of them, and factoring is the easiest way, but if it doesn't work, we have to go use different method. That's why it was a little more confusing. It was a little more than just factoring and finding out the zeros. I had to find the zeros first, and then using those zeros, write it in a factored form. Listen, this example is not the easiest. So what I will do is I created a similar problem for your daily problem, but I also have an additional example. So when you guys start on the daily problem, I want you to, if you need, I want you to watch that additional problem video, take note, and I want you to try one that is similar to this. It's going to be very similar to this, and submit that for this week's daily problem. Okay, so that's it for section 2.3.